Hello, welcome to Normal My Science Just Online. Today we are looking at the meter bridge. We have discussed the potentiometer, the Wheatstone bridge. So now we are looking at the meter bridge. All these instruments, they all have almost similar application. The meter bridge is also used to measure unknown resistance, just like the Wheatstone bridge. Is that okay? So that is what we're going to discuss. Then we'll do some calculations on it. These are very short topics, so please, if you are ready, get your writing material so that we can go straight to the class. But before then, please, if you are just visiting this channel, this is Normal Science Tutors Online, and we are teaching physics. Is that okay? We are teaching physics online, so this is your online physics class. If you are a returning subscriber, you are welcome. Please, have you invited your friends? Invite your friends, invite your colleagues so that they can also come and enjoy what you are enjoying. Alright, so give us a thumbs up, give us a like, give us a positive comment. You can reach us through the WhatsApp link that is showing down on this video or through the WhatsApp number that is showing on your screen. So that's okay. If you have any challenge, just let us know. We are there to help you. Okay, so welcome to this class, and if you are ready, please let's go straight to our class for today. So as I said, we are looking at the meter bridge. So the meter bridge is a specialized form of the Wheatstone bridge. So it is a special application of the Wheatstone bridge, and it is used to measure an unknown resistance. Okay, so this is basically the setup of a meter bridge. So you have two resistances that are connected here. Okay, so it consists of a uniform wire AB 1 centimeter long. Okay, so this is the uniform wire. Okay, it's about 100 centimeter long, which is a 1 meter wire. The ends of it are soldered to copper strips. Then the unknown resistance and the known resistance are connected across the gaps. You can see that. Okay, you can see these are the known and the unknown resistance. By closing the key, the jockey, this is the jockey, and this is a galvanometer. This round, this is the galvanometer, there's the jockey. By closing the key, the jockey is moved along the wire until a balance point is obtained, and then the galvanometer reads 0. Don't forget that it is only when the galvanometer reads 0 that you have a balance point. Okay, so when there is a 0 deflection. Okay, so if we use the Wheatstone bridge relation, we know that in the Wheatstone bridge we have this relation R1 over R2 is equals to R3 over R4, and for this meter bridge, R3 is equals to L1 and R4 is equals to L2. So if we use our relationship, we are going to have this, and this is the equation we need to solve for the unknown resistance, or the unknown resistance in the meter bridge. Okay, so when you are using the meter bridge, there are some precautions that you need to take. One of them is that the jockey should not be scratched but tapped lightly on the wire. So when you are using this jockey and you are carrying out a meter bridge experiment, just use to touch it, don't scratch it. All connection must be tight to avoid current leakage. 3. Switch is made open when readings are not taken so that battery will not run down. So when you are taking your reading, open the switch. Or when you are taking your reading, once you have taken your reading, you open the switch so that your battery will not run down. The battery case should be closed before the jockey is tapped on the wire. So you make sure that the circuit is completed before you start to tap the jockey on the wire. So these are some of the precautions that you need to take in case you have to carry out an experiment using the meter bridge. Alright, so basically this is it. So we are going to solve some problem now so that we can also see how we can apply that formula to find an unknown resistance. Alright, so this is a sample question. It says that in a meter bridge experiment, there is a 0 deflection of the galvanometer when L1 is equal to 40 centimeters as shown in the diagram below. Calculate the value of the resistance. that is calculate the value of this unknown resistance. So for meter bridge is very simple. You just write that R1 all over R2 is equals to L1 all over L2. Okay, so here you are giving your R1 to be equals to 10 ohm. R1 here is given to us to be 10 ohm. R2 is unknown, and L2 is not also given to you, right? L1 is given to you to be equals to 40 centimeters. All right, so you know that the meter, the rule or the length of the wire is 1 meter, which is 100 centimeters. So for you to get L2 will be equals to 100 minus 40. So please take note of this. So and that gives you what? 60 centimeters. So now we know L2. L2 is this. So from this formula that we have, we can just substitute to get our R2. So you have 10 all over R2 is equals to L1, which is 40 all over what? 60. So R2 will be equals to 60 multiplied by 10 all over 40. Okay, so by the time you work that out, you are going to have that the R2 will be equals to what? Your R2 will be equals to 15 ohm. Your R2 will be equals to 15 ohm. Okay, so I hope this is basically simple. You saw how we got your L2, we get the L2 and then apply it in solving the problem. Okay, so I think it's simple and it's direct to the point. This is another sample question. So in a meter bridge experiment, two resistors 2 ohm and 3 ohm occupy the left and the right gaps respectively as shown here. Okay, find the balance point from the left side of the meter bridge. Find the balance point from the left side of the bridge. So in this question, you are given R1 to be equals to 2 ohm, R2 are beginning to you to be equals to 3 ohm. Now you are asked to find the balance point from the left side of the bridge. Now the left side of the bridge is L1, so you have L1 is there already, it's given to L1. Then if the balance point L1 is known, right, then L2 will be equals to what? To be equals to 100 minus L1. So if L1 is equals to L1, which is known from the left hand side, then L2 on the right hand side will be equals to 100 minus L1. Okay, so now we can now substitute this into your equation. R1 all over R2 equals to is R2 all over L1 all over L2. So don't forget that what you are looking for is your L1. So substituting into this equation, you will now have that 2 all over 3 is equals to L1 all over 100 minus L1. Okay, so you can do your cross multiplication here so that you have that 2 multiplied by 100, 2 multiply 100 minus L1 equals to 3L1. Alright, so multiply that out. You can have, this will give us 200 minus 2L1 is equals to 3L1. Okay, so now you collect your like terms. So you have 200 is equals to 3L1 plus 2L1. That is 200 is equals to 5L1. So your L1 is equals to 200 divided by 5. And that gives us 40 centimeters. So the balance point from the left hand side is 40 centimeters, and then the balance point from the left hand side will now be equals to 100 minus 40 centimeters. So your L2 will be equals to 100 minus 40, and that gives you 60 centimeters. So with this, you have been able to find the balance point for both the left hand side and the right hand side. Left hand side 40 centimeter, right hand side 60 centimeter. I hope this is quite simple and it's easy for you to follow through, right? So thank you so much. I hope this is simple and you can follow through and relate to it. Alright guys, so please try your hands on this, solve this problem, and then this is a JAMB objective question, right? So solve this and then try other problems too in your textbooks. Please don't forget to always accompany whatever you are learning in this channel. Accompany it with your textbooks. Is that okay? Let your textbook always be by your side, and I recommend New School Physics. It's very good. Then if you have comprehensive physics, also good too. They are very good material that you can actually use to support whatever you are learning. Okay, so even if you also have a LAMLAD, yes, LAMLAD physics is also very good too. So please just use those materials together with whatever you are learning here, so that you can boost and increase your knowledge. So thank you so much guys. This is where we are ending our class for today. Before I leave, please, if you have not subscribed, please subscribe to our channel, give us a like, give us a thumbs up, so that whenever we upload a new video, YouTube will notify you. Also click on the notification bell, right? Click on the notification bell, then invite your friends. Let them come and enjoy what you are enjoying here. Okay, so thank you for your time. We appreciate you. You can place your comments on the comment section of this video, or click on the WhatsApp link and you can reach us and join our WhatsApp group chat. So thanks, and wish you the best in your learning and in your other educational pursuits. See you in our next class. Have a nice day.